how do GPUs enable XVA pricing risk simulations for the banking industry? So, quick show of hands, who knows what XVA is? Okay, at least half of you, so I don't need to go into too much detail about setting the scene. But the X in XVA essentially means different kinds of risk calculations. First there was CVA, then there was DVA. If you see a K, it's capital. But essentially what is XVA? It's risk modeling. What we're essentially doing is bringing enormous computational approaches to bear on large data sets in order to figure out what is the position of the bank during every second of the trading day. And it's all about computing the potential risk to the bank, right? Always monitoring what the traders are doing, monitoring what the markets are doing, and essentially ensuring that the bank doesn't lose its shirt if the markets change unexpectedly. I promise I won't mention the financial crisis of 2008 because we're all sick and tired of hearing about that. I lied, I will mention it. Before the financial crash, all trading was done without any real understanding or feeling for not only current values, but values of the trade in the future. So there's very little modeling taking place. The traders didn't really care what the value represented by the trade was next year or in 2 years' time or 5 years' time. And it was kind of irrelevant what the cost to the bank of the trade was in a year's time. What happened? What was important to the trader was what is the value of this trade here and now. That led to some very complex portfolios emerging, and we know what happened next. The crash occurred because the banks didn't really understand what they were trading anymore. So major reform ensued, and things like the Basel Accord was put together to make sure that the banks could model the data and analyze the trades effectively and store the data to measure their exposure at all times. This was bad news for the banks, though, because they had to collateralize everything. They had to make sure that the trades they were conducting could be capitalized, right? So they had money in the bank to make sure that if anything bad happened, they wouldn't go under. But this represents massive drag for a bank. This is really bad news if you have additional expense and reduced profitability. This is really bad news if you're a bank. So how can you trade safely, and how can you keep the regulators happy? Well, you need lots of data. You need all of the trading data. You need all the market data, currency fluctuation data, even social media data to reveal trends and patterns as they emerge in real time. You need some pretty clever models, and you need a lot of computational horsepower, because not only are you computing XVA as the trade occurs, you also have to recompute all of your trading activity and reassess the bank's position if there's a major fluctuation in the markets. So it's a big computational challenge. Fortunately, we have GPUs to help with that challenge, right? So before GPUs made it into the mainstream, in the banking fraternity at least, there were large estates of CPU-only servers computing risk, and it was slow, and it was very often batch. There wasn't enough horsepower to do these calculations in real time. Fortunately, with GPUs, the GPU device, of course, has of the order of 4,000 cores per device. This is great for heavy lifting, right? So analyzing, processing data in real time, it's an excellent technical fit. And it has to be very performant, because there are millions of trades taking place daily. Tens of thousands of counterparties are involved in those trading events. Scores of currencies are involved. All of this data needs to be mashed together and taken into account by the model, by the simulation. The kind of simulation that's being used for XVA is Monte Carlo simulation, and this is notoriously heavy in terms of its computational demands, and it just so happens that these kind of simulations work really well on GPUs. You probably saw this chart in Jensen's keynote yesterday. He did a much better job at explaining it, but I take two observations from this chart. The first is, if you're going to make advantage of all the transistors, you're going to have to do things in parallel. There's a law that's called Amdahl's law that explains that very thing. You cannot expect to do things in a single-threaded way and expect to get the results that you desire. So you have to do things in parallel, and that's something that Kinetica does very well. So we're a parallel processing database. We're massively scalable and distributed. So it enables us to get our arms around very large data sets. And by leveraging the GPUs and in-memory processing, we can do the risk simulation computation in real time. SpecInt, by the way, is an industry benchmark around integer processing speeds. And as you can see, that's tailing off, which Jensen explained was an unfortunate Moore's law factor right now. This chart basically shows you the enormous processing potential enabled by GPUs. As Moore's law tails off, GPUs are picking up and filling that gap and providing products like Kinetica with a lot of valuable horsepower. We don't need to go into detail on GPUs. Jensen showed you the V100 yesterday in his keynote. That's the latest GPU. It's got 21 billion transistors on it, apparently. And these are perfect for analytics. We use them for analytics. We don't use them for image processing or image recognition. We are accelerating database operations with GPUs inside Kinetica. So all the aggregations, the filtering, the sorting, computing statistics, we're doing all that on GPUs and in system memory on the servers, on commodity servers. And the great thing is they lend themselves very well to parallel processing. So what are the specifics around deploying XVA on GPU-accelerated software like Kinetica? So this is describing one of our deployments here in Europe, actually. It's a global bank, and they're providing the traders and the auditors and the management with statistics around the trading activity as and when it's happening. And they're also storing the trading activity for months. Actually, they want to store it indefinitely for years because it's extremely useful to be able to analyze that data to look for trends and patterns historically. And you may need to dip into the data, 7 years down the line if the auditors, if the regulators want to see it, perhaps. So it's really important that you've got a system that's powerful enough to be the system of record, is powerful enough to do the XVA computations and simulations, and also support the user community that are consuming this information using whatever tools or SQL, whatever they want to do. So a couple of aspects of Kinetica that I want to point out. So we provide all the connectors and adapters to tap into the source data. So the source data, it's live trading data, it's currency, it's FX data, it's coming in from a variety of operational systems. And this particular customer likes to use Kafka to stream the data in. So we're streaming data in near real time into Kinetica. There's also some reference data. There's data coming from data warehouses like Oracle and so on. So this data is being brought together for the first time in Kinetica. All this data hasn't existed in the same place before. So it's become a very valuable resource for this particular customer. So our customers can use any of those tools that are on this chart, any of the open source data integration tools, any of the mainstream ETL products will work. But the whole point is being able to tap into multiple sources of data, be it real-time or batch, and get the data into one database and have it transformed, cleansed, and then fed to the simulation. So not only can we run SQL on the data, we can also do programmatic algorithmic things with the data once it's in the database. So this is where the XVA model sits. This is where their Monte Carlo simulation is running. It's actually written, theirs is written in C++ and is running on GPU. It's using the CUDA development kit, and the beauty of this system is that they're able to do all of this in one system. Okay, so you've got all of the data, you've got all of the users served by it. You don't need another cluster for MongoDB to present the data to users, for example. You don't need another Spark cluster to do some algorithmic computations or streaming. You can collapse all those clusters into one system now and do it all in Kinetica. Something that's really exciting to this particular customer is being able to also leverage TensorFlow in the same server and on the same data. So again, it's one copy of the data, and they can let the data scientists loose in this environment. And of course, by definition, TensorFlow is GPU accelerated, it's ready, so they can do whatever they need to do, linear regressions, clustering, more simulations. There's a hell of a lot of algorithms in TensorFlow that they can bring to bear, and that's kind of like a stage 2 of this particular project. And then on the consumption side, we're just an ANSI SQL database with ODBC and JDBC drivers, so the bank use their existing tools to access the data. Some of our customers create their own interfaces with JavaScript, for example. We've got all the APIs to enable that. So XVA model running in database alongside all the combined, consolidated, and joined and cleansed data. One significant difference between Kinetica and an open source big data solution is that it's one vendor's product to install and maintain. There's no like a bag of software components that you have to keep in sync, and this is just one throat to choke, right? One vendor's solution, and makes it much more quicker and easier to deploy and maintain going forward. This is what the UI looks like. So this was a prototype user interface that was created with this particular customer. It's using our own visualization tool, which we call Reveal. And Reveal is based on an open source tool from Airbnb, actually, called Caravelle. And it allows the user to create very quick real-time dashboards that are interactive. Essentially, it just generates SQL behind the scenes, which run on Kinetica. But this tool enables this customer to do something they've never been able to do before, and that's see trading data at a very high-level view. There's a tree control that's not shown here, but there's a hierarchy that shows all the counterparties. So they can see the trades between counterparties. They can roll it up to global level. They can drill down into regional and country level, and they can see the trading activity, and they can see all those XVA metrics displayed along the top there for at any level in the hierarchy. And that's really important. If you're a trader, you can see your own trades, but you can also see trades by sector, by country, by counterparty. So they can they're basically slicing and dicing the data by any attribute that they want to. And some of the data is revealed at the bottom there. That's the raw data that we're storing in the database. And this is what's been computed by that XVA algorithm, the Monte Carlo simulation. So it's the historic analysis which is the real value add, though. Not only are we able to produce these stats at real time during the trading activity, but we're laying this data out for months or years. So we can go back and examine the data, look at the trading activity, look for anomalies, look for fraud even, and also keep the regulators happy by keeping it for years and years. So financial services for Kinetica is our number one vertical. It's our most active industry. We operate in all sectors, but financial services is the most dramatically busiest sector for us because of the amount of change in financial services. Banks need to deliver on open bank directives, for example, letting the customers in to do their own banking and operate with the bank's backends. They need to be able to better be more resilient, for example. The regulators are continually coming out with new targets. MiFID II, for example, coming in January. That's showing no signs of stopping or slowing down. So these are some of the reasons why financial services is the most interesting sector, the most active sector for Kinetica. So finally, a quick summary of what Kinetica is. So it's an in-memory GPU-accelerated relational database. It was actually a technology that was incubated by the US government originally for intelligence purposes, but now it's used in every sector, every vertical, from energy companies to retailers and phone companies. They've all got several things in common. They've got streaming data challenges. They want to move away from batch, and they want to be able to give users and applications access in real time to large volumes of data. Because of where we came from, we've got some interesting geospatial functionality as well. So we're able to store geospatial data and analyze that. We have all the functions built into the system to do geospatial analytics and serve maps up extremely quickly. We actually use the GPUs to do map rendering, which is something the GPUs were originally designed for, of course. So we can produce billions of data points on a map in sub-seconds times. We also have natural language search built in, so you can do text search, particularly useful in financial services for fraud and looking for individuals' names, company names, and variations of organization names and so on. So we're built for real-time data ingest, and we have all the adapters and connectors provided for that. It's deployed anywhere, so you can deploy in the cloud. We're on the Azure Marketplace, for example, similarly on AWS and Google Compute. You can deploy it in your own data center as well, of course. And coming at the end of this month is the brand new Kinetica Community Edition, which you'll be able to download and use the fully functioning product for free for 90 days. So that's released in just a couple of weeks' time. As I said before, it's scalable. So this is a fully distributed software stack. So you can spread this, install this on as many servers as you need capacity for. And we have direct integration with a number of data integration tools. And we're also working on new integration with data science workbenches like the likes of fuzzy logic. If you use Tableau, we're fully certified with Tableau as well. So you can work seamlessly with Tableau and accelerate the workbooks. And finally, just to look at some of our customers. And in financial services, we're being used for risk modeling, for example, financial crime and anomaly detection, compliance, and customer 360 applications as well. So that's all I have. I'll open the floor up to questions. Sorry about the delay at the beginning.
Thanks, James.
Thanks.
Questions? Yes.
You mentioned everything is stored in one system, and on the slide, there was a sign that one server, two servers or more. Let's say, how is scaling done, and what kind of or volumes of data you can keep, and what does that eventually mean to the license I'm paying?
It's so we're bound by the amount of memory in those servers. Because we're storing all the data in memory as well as on persistent storage, of course. So that's the limiting factor is the amount of memory, and that's also, by the way, how it's licensed is by the amount of memory that's in those servers. A typical server that we're deployed on has up to 1 terabyte or 1.5 terabytes of memory, and our compression techniques give you 3 or 4x compression. So you can use one server to give you several terabytes of data availability. And of course, if you need more capacity, then you just simply scale out and add more nodes. And we distribute the data evenly across all of the nodes automatically using a sharding strategy. Yeah, limitations. There's no technical limitation on the maximum number of nodes that we can scale up to. So our largest customer is the United States Postal Service, and they've got of the order of 80 terabytes over 7 clusters, each cluster with 5 servers. So it's pretty large, and that's serving 20,000 concurrent users though, and it's highly available. It's not active, it's active. So it's a very resilient and heavyweight deployment for us with lots of concurrent users. Our bottleneck, to be honest, there's only one, and that's how quickly can we get data to and from the GPUs. That's where our patents lie. That's the clever bit, is using some vector processing techniques to only get the data to the GPUs as and when required, and not overloading the bus between system memory and CPUs and GPUs. That's the clever bit. Consequently, that's why we like NVLink. NVLink makes our software 3 times faster, but it's not mandatory.
Hi. So when you say XVA model, so you are using here the model of your client, and if yes, so if you change a client, so you are going to use another model. So how it can be considered as a drawback in your system? Or?
It's a bring your own algorithm model. So it is the customer's code, the customer's proprietary algorithm. It seems to me it's a bit of an arms race right now. It's all the banks are weaponizing, right, and it's all about getting the best model essentially. So they don't share their model with us. It's very sensitive, and every bank has their own variation on the models that they run, and they keep them secret. So we don't have a model. What we give you is the platform on which to design and develop your own models, or write your own models, or use TensorFlow. There's a huge portfolio of algorithms that you can potentially use there.
Hello? Yeah. You're saying it's totally integrated system, no other software stacks are needed, etc. How do you schedule, prioritize, and security-wise segregate your computing streams?
Yeah, so because of the intelligence services background that we have, there's a lot of security features built into the product already. So from an enterprise point of view, it plugs into LDAP and Active Directory and Kerberos and so on. It also has role-based access control built into the database. So you can have a multi-tenanted deployment where user X can't see user Y's data and vice versa. So you can lock it down like you would expect with any relational database. In terms of workload management, we actually have very lightweight controls there. Because all of our queries run in milliseconds, we don't have to be too worried about contention of resources. So our workload management controls are very, very simple and lightweight as a result. We don't get much contention for resources because the queries are in and out so quickly. Because they're running in memory and they're running on GPUs, so they're bound to be fast.
That's true, but like when you run your end of days, end of weeks calculations, that consumes a lot of GPU capacity. We do that, for example, 3 times a day, because 3 world time zones. And in the meantime, all the traders want to do their inception pricing, and there are no GPUs available because they're all fed up with the end of day work. How do you?
So right now, it's kind of a static configuration. You have to configure for the worst possible workload scenario and have the necessary number of servers and number of GPUs available for the worst case scenario. But something we're working on in the engineering function is to make it more elastic, and that will dovetail quite nicely with our cloud offering. So yeah, watch this space.
Okay, thank you.
Okay. Any more questions? Yes, a couple here.
What sort of solution design do you do when, say, you want to do like time series kind of queries? So this is near-term data, but say they want to do a query over the 200 days.
So yeah,
you've got a bridge to the other system.
We've got some optimizations for time series data, and probably 90% of our deployments are on data that is time series. It could be IoT data, trading data in this case. So yeah, we have some mechanisms in the product. So scans are extremely, extremely fast when you're constraining on timestamps. We have optimizations for that, and it's never like a full table scan nightmare scenario where you're left waiting. It's we do all the kinds of things that you expect, but we do them a lot faster, including multi-way table joins, and it's a pretty robust and mature database, relational database that we've designed.
And one more question: what level of SQL support is it? And
ANSI 92 today,
okay.
And about 3 months from now, it'll be ANSI 99 compliant.
And any limitations on the joins you can do?
No.
Okay.
No, multiple different join techniques are used. The optimizer will pick the right one. You can have n-way joins, multiple way joins. Yeah.
As long as you've got the memory.
Yeah.
Okay.
So on which kind of operating system does it run? And
Linux.
Linux, okay. And are you planning to support these new non-volatile memory systems? Because they offer way bigger storage capabilities.
Yeah, good question. So we are totally agnostic in terms of the hardware we're running on. There is a sweet spot in terms of the amount of storage, amount of memory, and number of GPUs. But it's typically a standard server from HPE or Dell, or a standard instance on the cloud from Azure or whatever. And similarly, the storage that's directly attached to the nodes that we're running on can be anything. If it's development and testing, you could get away with spinning disk. If it's a production deployment, it'll probably be SSD or flash-based storage, RAID 10 typically. But we don't mind what we're running on. It could be any hardware. We like NVIDIA's hardware. DGX is fine. Similarly, IBM Power is fine, or it could be a plain old DL380 from HP. We don't care.
Okay, and when the memory gets way bigger with these new storage capabilities, probably there is a bottleneck with the CPU then, or do you think that?
Well, we're not anticipating any CPU bottlenecks because we're actually leaving all the boring work to the CPUs. So they don't do an awful lot. We do use them for compression and decompression. We use them for maintaining user sessions and ingesting data. But all of the heavy lifting is done by the GPUs. All the filtering and sorting, aggregating, joining, computing stats, it's all done by GPUs. So the CPUs kind of twiddling their thumbs a lot of the time.
Okay.
Okay, any final? Yeah.
Does Community Edition mean open source on GitHub?
No, sorry. Simple answer to a simple question. No, we've no plans to go open source.
Is there anything on the roadmap to be supported on top of frameworks like Mesos?
I don't know the answer to that question. I'll find out for you. Come by the booth, and I'm supporting the booth in the exhibition space, so we can talk some more about that. But you can use Docker. I know you can use Docker containers and deploy Kinetica in a Docker container, if that helps. Mesosphere, I'm not so sure.